Hi everyone, this is notes for 5.2 bisectors of triangles. And there's a lot of drawing that has to be done with this lesson, and of course I'm on the iPad, so you're going to have to just bear with me when I try and draw things without the use of a compass. But we'll do our best, okay? So first of all, we have to do a little bit of vocabulary. The first thing is called the point of concurrency. And the point of concurrency is a point where three or more lines coincide, or in other words, they intersect. Okay? The circumcenter of a triangle is a point of concurrency, meaning it's a place where there's three or more lines intersecting. It's a point of concurrency of, excuse me, the three perpendicular bisectors of a triangle. So you have a triangle, you go to each side, find the perpendicular bisector, draw the line, and where those three lines meet, that's your circumcenter of a triangle. And then the word circumscribed, that means each side of a polygon not necessarily just a triangle. This you could circumscribe any kind of figure, but each side of a polygon is tangent. And when we say the word tangent, we mean touching at just one point. Touching is tangent to the circle, okay? So let's just read this through one more time. Point of concurrency, a point where three or more lines coincide, or in other words, they intersect. The circumcenter of a triangle is the point of concurrency of the three perpendicular bisectors of a triangle. And when a triangle is circumscribed, that means each one of its sides, it goes for any polygon. Each one of the sides is tangent to the circle. In other words, it's touching it in just one spot. Okay, so there's a little bit of vocabulary. So we have this triangle here. And remember in class we kind of reviewed how to use our compass to do perpendicular bisectors. So of course I can't use a compass here, but I'm going to kind of show you what that's going to look like if we were to bisect this triangle. So on each side you would use your compass to find the midpoint of the line segment and then construct a line that's perpendicular to that line segment. So if I were to construct that perpendicular, then we would know these are right angles, and then this segment would be congruent with that one. Then we'll go to this side over here, and if we find the midpoint and then construct a perpendicular bisector, we go something like that. We would have a right angle, and this would be congruent with this. And then finally we have one more side to do, and that is this side right here. So we find the midpoint. Let me use a different color. I'll use green. We find the midpoint, and when we draw the bisector, it goes something like that. Okay? Now, again, you would be using a compass to construct your arcs so that they bisect like that. and then you would do your bisector, but you know, I'm on the iPad, so I can't do that. So this point right here, where the three lines intersect, that is not only a point of concurrency, because it's where they intersect, but that is the circumcenter of the triangle. And the circumcenter is equidistant. We talked about that word yesterday. Equidistant means it's the same distance to each of the vertices. So basically what we're saying is that if you were to draw a line from this vertice here, like this, and you were to measure those, you would find they all have exactly the same distance. So this is going to be important, an understanding of that when we do proofs going forward. Now, if I were to circumscribe this this triangle, meaning if we were to draw a circle around it, we'd take our compass and put it at the circumcenter, and we would measure over to the distance of one of the vertices, and then keeping our compass at that exact distance, we could draw a circle and it would come around like so and touch each of the vertices. Now I'm not gonna draw the whole thing, but you get the drift, right, on how it works. Again, I'm doing that freehand, not with a compass, so obviously I'm not doing the best job on it. Okay, so important. The circle circumscribes the triangle. Now remember what we talked, what I mentioned about circumscribed. That means it goes around and it is tangent. Each side of the figure is tangent, means it hits the circle in only one spot. It circumscribes the triangle, and the circumcenter of the triangle, meaning this point right here, the circumcenter is also the center of the circle. So let's think about what we've drawn here. I forgot to put my little congruent marks. We found the midpoint and did perpendicular bisectors for each side, and where they intersect is the circumcenter. When we construct lines or draw lines from a vertex to the circumcenter, each one of those lines is going to be equidistant to the circumcenter. And then each of the line segments that are created by the bisector, of course, are going to be congruent on each side of the triangle. Okay? So now what I want to show you is, see the little four triangles that are below, that although this circumcenter is in the middle of the triangle or on the inside of the triangle, it's not necessarily always going to be that way. So let's take a look at these other triangles. Okay, so on an acute triangle, we would find the midpoint of each side and construct a perpendicular bisector I'm going to kind of do it freehand again. Got this one. And this one. Oops, hard for me to do. Oopsie. And so those are congruent. And then finally, this one here. And there's our circumcenter. So on an acute triangle, the circumcenter is inside the triangle. Now, why don't you see if you can sort of sketch the perpendicular bisectors of the three sides of these other triangles and figure out where the circumcenter is going to occur. So go ahead and hit pause, give that a try, and then I'll catch up to you here in a minute. Okay, so I was trying to draw those things and ended up deleting the whole picture, so I had to do them all over again. So let's look here. We already said on the acute triangle, it's going to be on the inside of the triangle. There's your circumcenter. And then on an obtuse triangle, you'll notice that the circumcenter is on the outside of the triangle. And on a right triangle, it ends up being on the midpoint of the hypotenuse. And then an equilateral triangle, of course, is a form of an acute triangle, so it's right here in this center. And all these sides, the bisectors, all have the same measurements because the sides were all the same to begin with, and so when they're bisected, all of the line segments are going to be the same. Okay, so let's move on. Okay, so let's look at example 1 right here, and if possible, try to ignore this down at the bottom. It should be on the next page. Okay, so it says R is the circumcenter of triangle OPQ. And it says OS is equal to 10, QR is equal to 12, PQ is equal to 22. Find OP, RP, OR, TP, and RT. Okay, so let's see what we can work out here. Okay, so let's mark what we know. OR is 10, so we'll put our 10 here. QR, which is this line segment right here, is 12. And PQ is 22, so that's all of this is 22. Now, knowing that, let's think about what we know. Since this is the circumcenter, we know that the circumcenter is created by the intersection of three perpendicular bisectors. So let's take this side right here, for example, OP. This is at S is the midpoint because this is a perpendicular bisector. So we know if OS is 10, then SP is 10, right? And likewise, over here at QP, if the whole side is 22 and we have a perpendicular bisector at T, then we know this is 11 right here, and this is 11 right here. Now, some of these are ones that we don't necessarily have to say, but it's going to help us. Okay, so let's see here. I'm going to write down the ones that we need to find. We've got to find OP, and we figured that out because if OS is 10 and SP is 10, then OP equals 20. RP, now let's think about this. Remember from up above, once we have a circumcenter in a triangle, the that point is equidistant from all the vertices. So if it's 12 from Q to R, QR, then we know that RP is going to be 12 as well. So RP is 12. Okay, OR, again, same idea. It's equidistance, the circumcenter is equidistant from the vertices, so that's going to be 12. TP, not something you're going to use in the bathroom. This is line segment TP. We've figured out is 11. And then finally, RT, and this is going to be the one that's a little bit challenging. RT is this little side right here. So now, we don't have anything, we don't have a way of telling exactly what that distance is based upon just knowing that this is the circumcenter. But what we do know is that this right here is a right triangle, because if this is 90 degrees, we know that this is 90 degrees. So we have a right triangle with side 11 and a hypotenuse of 12. And so we need to find this side right here. So let's call that side A. So A squared plus B squared equals C squared. We can say A squared plus 11 squared equals 12 squared. So A squared plus 121 equals 144. Subtract 121 from both sides, and we get A squared equals 23. And how do we solve for A? We're going to take the square root of both sides, and so A is equal to the square root of 23. So that is going to be the measurement for RT, is the square root of 23. Now, what if I were to ask you what is the measurement of OT? Well, OT goes the whole way across there. But we know from O to R, OR is 12. So we would just write it like this: 12 plus the square root of 23. You can't combine those because you can only combine radicals with other like radicals. It's like x's can only be combined with other x's. So this is the way we have to show it. You cannot say 12 like this, because that would be 12 times the square root of 23. So we leave it 12 plus the square root of 23. Okay, good. Let's go on to the back. Okay, so we need to find the circumcenter of triangle RSO with vertices 0, 0, 0, 12, and 4, 0. So let's go ahead and plot these points. So R is at 0, 0, which is the origin right here. S is at 0, 12. So let's zip up here. Ooh, kind of hard for me to see. And that's 0, 12 is S, and then 4, 0 is O at 4, 0. So let's go ahead and draw the sides in. And it says find the circumcenter. So as you can remember, finding the circumcenter is taking the perpendicular bisector of all three sides of the triangle. So the two of these sides are going to be very easy, because let's look at line segment SR to begin with. This side, SR, is 12 units long, and so the midpoint is going to be at 6, and since it's on the y-axis, it's a vertical line, we can just make a horizontal line at 6, and we know it's perpendicular. And likewise, at 4, at RO, this is 4 units long, so we know the midpoint is at 2, 0, and vertical lines are all perpendicular to the x-axis, so we can draw that vertical line, and there's our perpendicular there. Now, the more difficult one now is going to be the hypotenuse, and you can already see where the lines are going to intersect is right here at 2, 6. But just so that you can see how that all works out, SO is at 0, 12, and 4, 0, right? 0, 12, and 4, 0. So I'm going to write those points. Here's the x, here's the y. 0, 12, 4, 0. Remember, the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if I were to add up the x's and divide by 2, I get 2. Add up the y's and 12 and divide by 2, I get 6. So there's our coordinate pair, 2, 6, right there where they're already intersecting. So it's cool. See, math is cool. It all works out. Now, if I were trying to try and construct the bisector, though, I have to know kind of what direction to go. So what we need to do is, I'm getting a little ahead of myself. What you would really need to do is get your compass and do it accurately, but I'm just going to draw it right through. I'm going to kind of estimate the perpendicularness, is that a word, of that line. And so there's our 3 bisectors, and the circumcenter is where? Right on the hypotenuse, the midpoint of the hypotenuse, 2, 6. Cool. Okay, now, okay, I did tell you one thing a little bit wrong. I mean, there is a way to construct that line very accurately even without your compass. It's because SO has a slope. If you look at the slope, it has a slope of 3 over 1. So negative 3 over 1. So if it has a slope of negative 3 over 1, perpendicular bisector is going to have opposite and reciprocal slope. So that's going to be positive 1 over 3. So you can just start at the midpoint there and do rise of 1 over 3, 1 over 3, and my hand drawing there wasn't very good, so it's a little bit too steep. Should have been right there. So I needed to angle it just a little bit flatter. But this is how you would figure out the slope. Since SO was negative 3 over 1, opposite and reciprocal would be 1 over 3, and that's how you could accurately draw your line. Okay, now let's go to number 4. Okay, so the question says mycelium fungus. Mycelium? I don't know. One of you scientist types can tell me how to say that. Grows underground in all directions from a central point. Under certain conditions, mushrooms sprout in a ring at the edge. The radius of the mushroom ring is an indication of the mycelium's age. Suppose 3 mushrooms in a mushroom ring are located as shown. Connect the points to make a triangle. I can do that. You can do that. So we're going to go like this. We're going to go like this. We're going to go like this. Be easier to do with a straight edge, of course. Now, it says each unit represents 1 foot. It says find the radius of the mushroom ring. Well, if we want to find the radius of the mushroom ring, all we need to do is find the circumcenter of the triangle, because we know If we find the circumcenter of the triangle, that will be the center of the circle that circumscribes the triangle. So now this would take a little bit of doing to do accurately. So what we would do is we could find the midpoint for each one of those line segments. So for example, AC is 2, 5 and 4, 1. So to find the midpoint, I'm going to add the x's and then divide by 2. So that gives me 3. Add the y's, divide by 2. So 3, 3 is the midpoint of line segment AC. So 3, 3 is right here. And then we can do the same thing for AB is 2, 5 and 6, 3. Add up and divide by 2. And we have 4, 4. So we go 4, 4, and it's right there. And you can see my drawings weren't that great. And let's see here. Then finally we have BC, and that's 4, 1, 6, 3. So that's 10, 4, divided by 2. So you get 5, 2. So 5, 2, and there's your midpoint. Okay, so then you need to construct the perpendiculars, and so we're going to need to find the slopes. So the slope of AC is going to be equal to, if we do rise over run, -2 over 1. So perpendicular slope would be 1 over 2. So I'm going to go back, whoops, we go back here, and oh shoot, look at what I'm doing. Well, you know what, it might not be a bad idea to start that over anyway, because we know our midpoints, and it'll be easier for me to draw anyway. So I'm going to put those midpoints back and draw our triangle. Boom, 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 like that. Okay, so the slope is 1 over 2. So I'm going to go to my midpoint. I'm going to go up 1 and over 2, up 1 and over 2, down 1 and over 2, and so the line is going to go right through these points. Then we're going to do the same thing for AB. Let's look at the slope of it. It has -1 over 2, 1 over 2, and so AB slope is -1 over 2. So perpendicular slope would be +2 over 1. So let's go to the midpoint of AB, and we're going to do +2 over 1, 2 over 1, and we can draw that line segment through those points. Oops. And then finally on BC, it has a slope of 1 over 1, 1 over 1. So it has a positive slope. So perpendicular slope is going to be -1 over 1. So that's going to go like this. And there's our line segment for that. And you can see the circumcenter right there. Okay, now look, I'm not going to answer the other questions. I'm going to leave them. I'm going to leave the other two constructions for what we're going to do in class. I think maybe we'll jump over and do number 5, but we can talk about the rest of this in class tomorrow. Let's jump over and do number 5 real quick, and then you'll be done. Okay, well, I lied to you, because the first thing we have to do is just talk about this triangle right here. 2 more vocabulary words. One is the incenter of a triangle. The incenter. This is different than the circumcenter. the incenter of a triangle is the point of concurrency. Now remember, concurrency is where things intersect, of the three angle bisectors of a triangle. Remember, the circumcenter was where the segment bisectors, perpendicular bisectors intersected. This is where the angle bisectors of the triangle are going to intersect. And then inscribed, it's a polygon in which every vertex of the polygon lies on the circle. So I'm just going to hand draw this for you real quick. We're going to bisect the angles. Bisect. Bisect. I don't know that I did that one very well. Let me try that again. That's a little better. And then we're going to bisect this one. And so this point right here is the incenter. And this is an important piece of information. The incenter is equidistant to the sides of the triangle. So it's kind of the opposite of what we were doing on the other one. If we were to take the shortest route to each side, meaning like a perpendicular, it's going to be the same distance for all of them. Okay. And then if I were to take this distance and, do a circle in here, we would of course use a compass to do this. So that is, we would say the circle that I just drew is inscribed in the triangle. Okay, so now remember, when you have angle bisectors, that causes these angles to be congruent. Okay, and then the equidistant sides, and there we go. Let's now do number 5. Okay, it says MP and LP are angle bisectors of LMN. Find the distance from P to MN, so we're trying to find this distance right here, and the measure of angle PMN. So PMN is, we're going to try and find this angle right here. Okay, so let's see what we know. Since this is an angle bisector, we know that this angle right here is the same as this one, so that's going to be 15. And we know that since P is where the two angle bisectors meet, this distance of 5 is going to be the same as this one right here. So that's going to be 5 over, not 5 over, it's going to be a distance of 5 from P to MN. Now let's see what else we know. Since these two angles were congruent and That adds up to 30, so we know this angle L is 30 degrees, and this angle N is 20 degrees. We can add those up to get 50, and subtract that from 180, and know that this angle M is 130 degrees. And so if we divide that by 2, we get 65 degrees is the measurement of angle PMN equals 65. Okay, that's it. I'll see you in class. Sorry for the long lesson. Bye.